Today in Brisbane is a bit of an interesting one. It is a loaded gun sounding, which would usually create or allow the possibility of very severe storms. The 0 to 6 kilometre shear is right up above 20 metres per second, which means that Ellen's discriminate's very high, but all of this relies upon the cap breaking, and I think the original maximum temperature forecast for today was about 32. Where I sit in Woodford, it doesn't look like it's going to get anywhere near that. So the question's going to be, will the cap break? But anyway, let's see. If it does break, then they will likely be rotating supercells, very large lots of rain. Great job.
Looking at this morning's Skew-T diagram, we are starting with a modest 134 joules per kilogram of mixed layer CAPE, shown by the small blue shaded area between the dashed blue mixed layer parcel path and the environmental temperature profile. The atmosphere is essentially uncapped, with no significant lid holding energy down. What's particularly interesting is the wind profile, showing strong directional shear with winds veering from light southeasterly near the surface to moderate westerlies aloft. The 0 to 6 kilometre bulk shear measures 20.4 metres per second, well above Australia's 15 metre per second threshold for organised storms. Surface temperature sits at 26 degrees with a dew point of nearly 20 degrees, providing ample moisture. The lifting condensation level is positioned at just 797 metres above ground, low enough to support organised convection if sufficient heating develops. This is a classic southeast Queensland preheating environment, where modest morning instability masks the true afternoon potential. Now let's examine the dramatic afternoon transformation on our heated Skew-T forecast. As solar heating drives surface temperatures from 26 degrees to a forecast maximum of 32 degrees, watch what happens to the instability. The pink and orange shaded CAPE area explodes to 1544 joules per kilogram, more than 10 times the morning value. This massive energy release is contained between the heated mixed layer parcel, shown in the thick orange dashed line, and the unchanged morning environmental profile. The heated parcel maintains constant mixing ratio as it warms, creating a powerful buoyancy differential. The blue shaded CIN, or convective inhibition, remains minimal, meaning there's no significant cap preventing storms from forming. The equilibrium level extends well into the upper troposphere near 160 hectopascals, providing deep convective potential. With over 1500 joules per kilogram of energy and strong directional shear still in place, the ingredients come together for organised multicell or possibly supercell thunderstorms. The lifted index drops to minus 1.9 degrees, confirming the atmosphere's eagerness to support vigorous updrafts once heating peaks in the early to mid-afternoon hours. The hodograph reveals crucial information for emergency services planning today. We are seeing strong 0 to 6 kilometre bulk shear of 20.4 metres per second with pronounced directional shear as winds veer through the vertical column. The wind vectors progress from light southeasterly flow near the surface, shown in the dark purple points near the origin, through stronger easterly flow in the lower levels, transitioning to moderate west-southwesterly winds aloft, represented by the yellow-green points extending to the right. The bunker's right mover storm motion vector, marked by the red star, points toward the south-southwest, indicating that if supercells develop, they will track toward the south-southwest at approximately 11 metres per second. This hodograph curvature supports supercell potential, with 0 to 1 kilometre storm relative helicity measuring 122 metres squared per second squared and 0 to 3 kilometre helicity reaching 258. For electricity restoration crews, this wind profile suggests conditions favour organised severe thunderstorms capable of producing damaging straight-line winds and potentially large hail. The combination of 1500 joules per kilogram CAPE and this deep layer shear creates a significant hail parameter of 0.84 and a significant tornado parameter of 0.37. While tornadoes remain unlikely in the Brisbane region, the primary threats are destructive winds from organised cells and hail up to golf ball size. Emergency services should consider prepositioning resources in northern and western suburbs, as the south-southwesterly storm motion would bring severe weather toward metropolitan areas from inland initiation zones. The atmospheric refractivity profile, or N profile, provides critical insight into downdraft potential and microburst risk for emergency planners. The blue line shows the Brunt-Väisälä frequency squared, essentially measuring atmospheric stability at each altitude. Starting near the surface around 1,000 metres, we see elevated duct conditions, indicated by the orange shaded bands, where refractivity gradients create favourable radio propagation paths. Moving upward through the boundary layer between 1 and 3 kilometres, the n-squared values remain relatively low, indicating weak stability in these layers. This weak mid-level stability is significant because it means descending air parcels encounter little resistance, allowing precipitation called downdrafts to accelerate efficiently toward the surface. The decape, or downdraft convective available potential energy, measures 323 joules per kilogram with a theoretical downdraft velocity of 25 meters per second, which translates to roughly 90 kilometers per hour. While this is below extreme microburst thresholds, it's sufficient for localized wind damage, particularly given the relatively dry subcloud layer with a surface dewpoint depression of 6 degrees. For state emergency service volunteers, this profile suggests moderate microburst potential exists if storms develop. The combination of 1500 joules per kilogram updraft energy and 323 joules per kilogram downdraft energy creates potential for intense pulse storms with brief but damaging wind gusts. The freezing level at 4,060 meters provides a favorable hail growth environment, with sufficient depth in the supercooled liquid water zone to support hail up to 2 to 3 centimeters in diameter in the strongest updrafts. Emergency services should maintain readiness for scattered severe thunderstorms through the afternoon and evening hours. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia. Always consult the Bureau of Meteorology for official warnings and forecasts. This analysis is for educational purposes only and should not be used as the sole basis for safety decisions. Stay weather aware and have multiple ways to receive warnings today.